Another quite common issue is what to do when your data have a big range. So here we have, say, the income of a company, and it's getting very large. This company must be like an internet startup company and growing very fast. Now, a situation like this, there might be uncertainties in the data points, but you can't, in fact there are actually error bars in here, but you can't see them because they're smaller than the dots. That's because the graph has auto-scaled to this enormous range because this company became so big towards the end, so you can no longer see the uncertainties. So what do you do in a situation like this? It looks like it's a beautiful fit, but is it really? Well, one thing to do, and this is always a good idea, is a residual plot. Residuals are the difference between the data and your model. So if you want to see, is this red line a good fit to the black data points? If you just plot the model and the data on top of each other, it will look like a good fit. I mean, look at that top graph. You couldn't complain about that. But the reason that you think it's a good fit is because the auto-scaling means you can't see the discrepancies. Down here is the residual. This is the difference between the data and the model. And now you can see it's not quite so perfect. In particular, there seems to be something funny going on around 2005 and 2007. The data is quite a bit lower than the model. So in general, if you're trying to be honest with yourself and say, do I really think this is a good fit? Always do the residual plot. If you're just trying to bullshit yourself or your boss that it's a good fit, then go with something like this. It's often a good job of hiding your discrepancies. But if you're an honest scientist, then residual plots are the way to go. Another thing you can do when you have data that spans an enormous range is plot the logs. So here what we're now plotting is the log of the income against the year. This is a very useful thing to do, particularly if you're trying to see if the percentage change rate is different. So for example, if a company is growing at a certain percentage a year, then it will be a straight line in a log plot. Whereas in a linear plot, like this one, it seems to do nothing, 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 then whoa, it goes up at the end. So if you're interested in percentage rates of change, then a log plot is the way to go. Whereas if you're interested in the total value, then a linear plot's the way to go. The way you do this in Python is first of all you set up a figure. The subplot command is what you use to plot multiple things on the same screen. Here what we're doing is we're plotting a subplot. You tell it how many across, how many up and down, and which one you're doing. In this case you want one across, one up and down, and one, which means it's just a single plot filling the entire screen. And then you set the x scale and the y scale of this figure to log, and you tell it what to do if values go negative, because the log of negative values is not nice. And clipping just throws away those negative values. And then you can use all the normal commands, error bar, plot, label, and so on, and it should all work and give you plots like this with an appropriately scaled logarithmic axis. You can do both the x and y axes as logs, or just one of them. And later in the course you'll talk about why you might choose one or the other.